In this video, we'll talk about how to find standard deviation by hand. Now, I will be the first to admit that this process is pretty tedious, especially for larger data sets, and it is always going to be faster to use technology to find it, whether it's using the graphing calculator or some spreadsheet program, Excel, something like that to find standard deviation. But I want to practice it at least once just so that we can see it in case we need to for whatever reason. So I've got my data set right here, 3, 5, 6, 7, 7, and 10. Now if you look at the steps right above this video on Canvas, I should have all 6 steps that we're going to follow, and I'm going to try and label these along the way. First step that we're going to do is we need to find the mean of this data set. So I'm going to find x bar, which means we first add up all of our data values, 3 plus 5 plus 6 plus 7 plus 7 plus 10, and then divide by the number of data values that we have. In this case, it should be 1, 2, 3, 4, 5, 6. So I'm going to divide that by 6. Let me grab my calculator so I don't make a silly mistake. 3, 5, 6, 7, 7, 10, and I end up with 38 in my numerator divided by 6. Divide that by 6. I ended up with 6.3 repeating. Let's just round that to 6.3 for right now. For most of the remainder of these steps, I think it's helpful to kind of organize your work, and I'm going to do that using a table. So I'm going to write out, here are my different x values. These are just the different data values that we have. We've got 3, 5, 6, 7, 7, 10. One thing to note is if you do have any repeated data values, we are going to use both of those. So we are going to want to make sure that we include both of those in our data set twice. And for each one of these, my second step was to say, okay, I'm going to take each one of those data values and subtract the mean. So I'm going to take x minus x bar up here. So, let me give myself a little bit more room. I'm going to take 3 minus 6.3. So 3 minus 6.3 gives me negative 3.3. And 5 minus 6.3. Subtracting that gives me negative 1.3. And 6 minus 6.3. 6 minus 6.3 gives me negative 0.3, and so on and so forth. 7 minus 6.3 gives me a positive 0.7. 7 minus 0.3, or excuse me, 6.3 will give me positive 0.7 again. And 10 minus 6.3 should give me a positive 3.7. So there's my second step. I've got all of my data values here. My third step is I want to take each one of those numbers that I found in step 2, and I'm going to square it. So I'm taking each x minus x bar that I found in the last step and then squaring it. So I'm going to take negative 3.3 squared. Now be extra careful here, especially if you're using a calculator, which I expect most of us are. You want to make sure we use these parentheses when we square this number because it will make a difference. Remember, when we square a number, we should always come back with a positive number, or perhaps 0, but most likely a positive number. So if I take negative 3.3 squared, I end up with a positive 10.89. Negative 1.3 squared. 1.3 squared gives me a positive 1.69. And then negative 0.3 squared, 0.3 squared gives me 0.09, 0.7 squared, 0.7 squared should give me 0.49, 0.7 squared gives me 0.49, and 3.7 squared gives me 13.69. So I have all of these data values here. These are the numbers that I'm interested in at this point because for my step 4, I'm going to take all of those numbers that I just found and I'm going to add them together. So for step 4, I'm going to take all of these numbers and add them together. So for step 4, I'm taking 10.89 plus 1.69 plus 0.09 plus 0.49 plus, we're going to add them together. So using my calculator, 10.89, 1.69, 0.09, 0.49, 13.49, and plus 13.69. Here I ended up with 27.34. Very cool. Almost done. I would say at this point we're kind of past the hardest part of this problem. For step 5, I'm going to take the number that I found in step 4, and I'm going to divide it by n minus 1. Now, n represents our sample size, or the number of data values that we have. So in this case, if we go back up, we've actually counted it before. We had 6 data values. We had 1, 2, 3, 4, 5, 6 data values. So I'm going to take that 27.34, and I'm going to divide it by 6 minus 1 is 5. So you can write in 6 minus 1 if you want, or you can just say, I know that that's 5. I'm going to take that divided by 5. So taking that number divided by 5, I end up with 5.468. There is my step 5. I have one last step to do. Now, actually, one thing I'll mention, if the problem asks you to find variance, which is not something that we use very often, this is our sample variance. So this is our S squared, or our variance. We tend to use standard deviation more often, but standard deviation and variance are very similarly related. Generally, if you're finding standard deviation, you kind of have to find variance along the way. So my last step then, step 6, I'm going to take the square root of this result. So I'm going to take the square root of 5.468 and grab my calculator, square root of 5.468, and that gives me 2.34. We'll just round to 2 decimal places right here. This is my standard deviation, S. So this is something that we can do by hand. It was, tedious to do with 6 different data values, but you can imagine that if we have larger